So we need to use the product rule here. The product rule is used when you have two functions that are multiplying by each other. So you can see how here we have our first function e to the x times by our second function cos of 3x. And the way the product rule works is that we take the derivative of the first function, so e to the x becomes e to the x, and then you times it by the second function, not changing it at all, and then you just plus the derivative of the second function now, so the derivative of cos 3x should be negative 3 sine 3x, and then you times that by the first function without changing that at all. So you can see how our final answer is this. For this question, we need to use the chain rule to first find the derivative. You use the chain rule when you have an outside function like the log e of something, and then an inside function like the cubic. So the way we do the chain rule is we need to take the derivative of the outside function just using its own rule. So to find the derivative of log e normally, you just do 1 over whatever's on the inside. So this is what we get. And then to finish off the chain rule, you need to times by the derivative of the inside function. So in that case, it's this. And then finally, we can write our derivative as one fraction. So we get this. To finish off our answer, we need to substitute 3 into our derivative. So if I put in 3, this is what we get. And then you can see how when we work out the top, this part here becomes 9. 9 times 3 is 27. Minus 3 is 24. And then here we have 3 cubed, which is 3 times 3 times 3, which is 27. Minus 9 plus 2. So that's going to be 20. Then if we divide the top and the bottom by 4 to simplify this, we get 6 over 5 as our final answer. So for this question, it asks us what value of k do we need so these simultaneous equations have no real solutions. And what I like to do with these types of questions is work through it visually. There's other ways to do it, but I feel like this makes the most sense to students. And what's really important to understand is that we can rearrange each of these equations into the form y equals mx plus c, so we can easily see their gradients and their y-intercepts. So I'll show you visually here what I mean. So normally when we have one solution, the gradients are different and the y-intercepts can be the same or different, it doesn't matter. But their intersection is our solution. Then we can have the same gradient and the same y-intercept that makes the same line, so you have infinitely many solutions. Or for this case that we want, we have the same gradients and different y-intercepts that will have two parallel lines that never meet and have no real solutions. So in this case, we want the gradient of one of them to be the same as the gradient of the other one, and we want the y-intercepts to be different. Okay, so I'll start by rearranging our first equation here. So I'll write it here. And what we need to do is rearrange it so we get the y by itself. So first we'll move this to the other side. And then we'll divide by -2. So normally you just divide everything by -2, or you can apply it individually to each term. In this case, I'm going to apply it to this separately and then to this part separately as well. And I'll explain to you why. So when we apply it to here, we get this. And then when we apply it to here, we get this. So this part forms our gradient because it's attached to the x, and the negatives cancel out, as you can see there. So for our gradient, we get 3k over 2, and then this part becomes our y-intercept. So this negative is at the front. When you bring it to the front, make sure that you put some brackets on the top because it belongs to the whole equation, not just to the front term. And now you can see how our gradient is equal to 3k over 2, and our y-intercept is equal to negative k plus 4 over 2. So that's for our first equation, and then for the second one, we can do the exact same thing. So for this one here, I'll write it down over here. All we need to do is rearrange this and get the y by itself. So first, move this to the other side by minusing it. So we minus it across, and then we divide through by k, doing what we did before, where we divide this separately, that becomes negative 1, and then divide this separately, that becomes this. So you can see how on this side, our gradient is equal to this part that's timesing the x. So if I write that down here, and then our y-intercept is that part there. Okay, now for no solutions, remember that our gradients have to be the same and our y-intercepts have to be different. So let's form an equation for our gradients. So we can say that the gradient of the first one is equal to the gradient of the other one. Now I'll just solve this for k. So I'll just use white. What we can do is first get rid of the fractions. So cross multiply, multiply this k across and multiply this 2 across. That gives us 3k squared equals negative 2k minus 4. Okay, then expand our bracket on the right hand side. And then move everything to the left so we get a quadratic that we can solve. There are different ways of solving this. You can use the quadratic formula, you can factorize this. I'll just factorize it. So what two numbers multiply to give you negative 24 and add up to 2? Well, that's going to be positive 6k and then minus 4. And then you just factorize this and this. So 3k comes out here. And then negative 4 comes out here. And then finally factor out this. And that leaves you with 3k minus 4 in the other bracket. And this whole thing equals 0. So now we can just use the null factor law. So looking at this, we get k is equal to, I'll write the whole equation actually. This is equal to 0. So k is equal to negative 2. Or the other bracket is equal to 0. And that will give us 4 on the other side. Divide the 3 across. So either of these can be our answer, but we haven't looked at the y-intercepts yet. So remember that we said that our y-intercepts have to be different. So if we make that equation, where we say this y-intercept here has to not equal the other y-intercept. And then we solve this. Well, I'll just multiply the 2 across. And then expand this negative. And then, actually, you should probably just multiply that negative through the entire thing to get rid of the negatives overall on the left-hand side and the right-hand side. And then finally, minus your 4 to the other side. So k is not equal to negative 2. So you can see how, based on looking at our gradient and our y-intercept, k should not be negative 2. So get rid of that answer. And our answer should be k equals 4 on 3 only. Next question. So here it wants us to draw this graph. Before we start drawing, it's important that we know what kind of graph this is so we know what it looks like before we start. So this is a truncus and it looks like this. Let's start with the asymptotes first. So our vertical asymptote is just the opposite of this number, or it's whatever makes this bracket 0. So in this case, it's negative 3. And make sure you label it. And then our horizontal asymptote is whatever number's at the end there. So that's negative 2. Now what we need to find is the y-intercept, and you find that by making x equals 0. So by making x equals 0, we'll get 1 over 3 squared minus 2. That's equal to 1 over 9 minus 2. And then to combine this fraction, this needs to get the same denominator, so the bottom number, so we times it by 9 over 9, and that gets us 1 over 9 minus 18 over 9, which is negative 17 over 9. We can label that here. And then we can also find our x-intercepts. So our x-intercepts happen when y equals 0. So we make y 0, and then we need to solve for our x. Add the 2 to the other side. And then what we can do is flip both sides to get this x out from the bottom of the fraction. So by flipping this, remember this is like that, that gets us 1/2. And then this gets us this. You don't need to write the 1 on the bottom. Then what you do is square root both sides. So by square rooting the left, you get plus or minus square root of 1 is 1, and then square root of 2. Remember the plus or minus whenever you square root. And then finally, moving this to the other side by minusing it, you get x is equal to negative 3 plus or minus 1 over root 2. And then we can make this rational by, so rationalize it by timesing it by that, and then this is going to give us negative 3 plus or minus root 2 over 2. It's helpful to know approximately what root 2 is, so it's 1.4, and when you divide that by 2, it's about 0.7. So this lets us have an idea of where exactly on the x-axis we need to put our x-intercepts. So if you think of it like this, negative 3 take away 0.7 is negative 3.7, and then negative 3 plus 0.7 is negative 2.3. So when you're labeling it, don't use the decimals because the question doesn't ask for that, so you need to put your exact values. But now we know around where to put them, so we can put one there and then the other one here. So label this one as negative 3 plus root 2 over 2, comma 0, and then label the other one as negative 3 minus root 2 over 2, comma 0. Now that we've done that, it's important just to find one more point so our graph is really accurate. An easy point to put in is negative 2, x equals negative 2. If you put that into here, you can see how this bottom bit here will be negative 2 plus 3, which is negative 1. When you square that, you'll get positive 1. 1 divided by 1 is just 1. And then you'll have 1 minus 2, which is negative 1. So we know at negative 2, our graph goes through negative 1. And by symmetry, it should go through negative 1 at negative 4 as well. Now, all that's left to do is draw a nice smooth truncus through all of these points, which I'll try to do now. Something like that. I missed that point, but you don't have to be extremely accurate, just close enough. And then just draw the same thing on the other side. So, like that. And connect it through like that. So you can see that looks pretty symmetrical and nice and smooth. This question is asking us to find the area between the line x equals negative 2, the x-axis, the y-axis, and the graph. You can see here what that area is. And you can see that the area is below the x-axis, so that makes the area negative. We want a positive area. So what we can do is, normally to find the integral in this case, you write the terminals from left to right. So you would write negative 2 to 0, but that would give us the negative area. We want a positive, so we can flip those terminals around and that'll make the negative positive. So instead I can write the integral from 0 to negative 2, and then we can take the integral of our graph. Now to make our life easier, we can rewrite this in a way that makes the integration easier. So you can write that first fraction as x plus 3 to the power of negative 2. So remember that you can bring this to the top as long as you switch the sign of the power, and then the negative 2 stays the same. So now our integral becomes that. And then to work this out, all you do is add 1 to the power here and then divide by that new power. So we're going to get x plus 3 to the power of -1 divided by -1, and then that -2 just gets an x added to it. And now we can rewrite this just to make it a bit easier, so we can write it as negative, bring that negative to the front, bring this to the bottom so we don't have that negative power anymore. So now we get that. And now we can substitute our terminals in and then work out the rest. So let's do that. So when we sub in our -2, we get this. And then you do minus, and then you sub in the 0. Perfect. So now you can see how this leaves us with -1. The bottom here becomes +1, so that's -1 over 1. This becomes +4. This becomes, let's see what this bracket becomes. This is -1/3. This is 0. So -1/3 in that bracket. And then this becomes plus. So now you can see how we get 1 or -1 plus 4 is 3. So 3 plus 1/3, which is 10 over 3 as our area. So for this question, it's super important that we know what n is. So n is this number here. That's how many trials we're doing. And then our p is 9 on 10. So that's our probability of success. I hope you remember that in order to find the variance, you follow this formula here. So when you square root both sides, you get the square root of the variance is the standard deviation, and you work it out using this formula here. So let's work out the standard deviation now. So using this formula, we get n times p, and then 1 minus p here. So you can see how this is going to get us 4 times 9 is 36 over 10. And then this is 10 over 10. 10 over 10 take away 9 on 10 is 1 over 10. And then we square root all of this. So once we do that, we get 36 over 100 square rooted. And that gets us 6 over 10. So for the second part here, it's important to remember what our n value was and what our p value was. Since this is a binomial distribution question, we'll be using this formula to work out our probabilities, and it cares about when x is less than 2. So all we care about is when x is 0 plus the probability of when x is 1. Since both of these numbers are less than 2. So using this formula, let's work out each one of these. So I'll start with this one first. So plugging our numbers in, we have n, our x is 0, our probability is 9 on 10 to the power of x, and then 1 minus 9 on 10 is 1 on 10, and then 4 minus 0 is just 4. And then let's do the other part as well. So that's 4 choose 1, 9 on 10 to the power of 1, and then 1 on 10 to the power of 3. Cool. Now, this is also really useful. So you can work out these individually by using the respective formula, but you don't really need to do that here, and that would slow you down. It's easier to think of it like this when you have easy numbers like 1 and 0 on the bottom. So if you have 4 objects, how many different ways can you pick nothing? Well, that's 1. You can just pick nothing once. There's no other unique way to do that. Here it's 4 objects. How many unique ways can you pick one object? Well, if there's 4 objects, you can pick 4 different objects. So that's the answer there. This is equal to 1. and then this stays the same, this stays the same, and so does this. So our next line should look like this. 1 on 10 to the power of 4 plus 4 times 9 on 10, and then 1 on 10 to the power of 3. Now what you can do is you can factor this out, and you can get 1 on 10 out here. That will leave only 1 on 10 once here, since there's 4 of them there. And then this will leave 36 over 10 here when you multiply 4 and 9. Then you can write this as 1 on 1000, and we're timesing it by 37 on 10. So 37 over 10. Whoops, over 10. And then that leaves us with 37 over 10,000. So that's our final answer. So in this question we have a hyperbola, and it wants us to use the model to predict the population after 4 years. So this gives us the population, and this is the time. So we put the time into the equation. So we find h of 4. That gives us 3,000 over 5, which is 600. For the next question, they want us to find a new function, or they want us to find the transformations on how to get this new function, where it decreases at half the rate of the original at any time. And the important thing is that the new one has the same y value at x equals 0 as the old one. So let's find what that old one is at x equals 0. Well, when you put 0 into here, or t equals 0, when you put 0 into there, you'll get 3,000 over 1, so that's 3,000. So our new graph has to also be at 3,000 at t equals 0, so the y-intercept. Now let's think of what half the rate means. Let's think of it in terms of gradients. So imagine we had a gradient of 4 going down and 1 across. Well, that's a gradient of -4. If I wanted it to be half the rate, so half as steep, all I would do is just halve the y value. And that would give me -2. So you can see how that is half as steep. Now if I wanted to do that across the entire graph, I would have to halve every single y value. And what kind of transformation is that? Well, that's a dilation of factor half. And since it's vertical, it's from normally the x-axis, so you would say dilation of factor half from the x-axis, but in this case the x-axis is the t-axis. So you write from the t-axis. And you can see on the right hand side how our graph has a gradient that you can see, and as we dilate it by a factor of a half, we're compressing the graph, and now it's less steep overall. But the problem is now that we've halved everything, our graph starts at 1,500, but we needed it to start at 3,000. So how do we get the 1,500 to 3,000? We just move the whole graph up by 1,500. So our next bit is translate up by 1,500. For this question, we need to use this formula here that you see on the side. So we need to find out what p hat is and what n is, and we know that z is 2. So remember that p hat is just the fraction of people in our sample that are unhappy with the roads. So here it says 60 people are unhappy, so p hat is going to be equal to 60 over 100, and you can simplify that by halving it, and then halving it again, and just divide it by 5. Or you can just think of what number goes into 60 and 100, so think of the biggest factor. But just halving it, halving it, halving it again is usually the easiest when you're in stress in an exam condition and you can't think of how to simplify it easily. So now that we have that, we know our n is just how many people we selected at the start, and that's 100. So we put 100 here, and now we can use our formula. So our formula tells us to get the confidence interval, you get your p hat and you plus or minus your z score, and then this portion here, which is your p hat, 1 minus your p hat over n. So let's work out what this is. Once we work that out, we can just add and minus it from 3 over 5 to get both parts of our interval. So I'll do it in a different color here. So what we can do is multiply what's in the square root. So that's going to get us 6 over 25 over 100. And then what you can do is you can just square root everything. So square root the 6, square root the 25, you get 5, square root the 10, square root the 100, you get 10. And then what you do now is remember that when you divide a fraction by a number like that, what you can do is just write root 6 over 5 times 1 over 10. Remember that by dividing a number, you can just flip it and times it as well. And then this is going to get us to root 6 over 50. And then you can simplify it to root 6 over 25. So now that we've done that, our answer should just be 3 over 5 minus root 6 over 25, and then 3 over 5 plus root 6 over 25. And now we can just combine these by multiplying the top and bottom here by 5. And then you can just have one fraction for each part of the interval. Oops, this should be a plus. And that's our answer. Next question. For this question, we need to use this part of our formula from before. This part is the part that represents our standard deviation. The question says that it results in the same sample proportion as before. So remember that our sample proportion before was 3 over 5, which we got by dividing 60 over 100. Now here it says find the smallest value of n to achieve a standard deviation of root 2 over 50. So we know that our standard deviation has to equal root 2 over 50. And using the right side of our formula, we can form our equation like this. So you put p and then 1 minus p over n. We don't know what our n is because it says to find n. All we need to do is just solve this now and we get our answer. So first what I'd like to do is get rid of the big square root on the right hand side. So what I do is I square both sides of our equation. So when you square root 2 you get 2, and square 50 you get 2,500. And then you times the fractions together and you get 6 over 25 over n. Now what I like to think of this is like this is its own number, this is its own number, this is its own number, and this one as well. And what you can do is to get the n out from the bottom of the fraction, you can flip both sides of the equation. So you get 2,500 over 2 is equal to n over 6 over 25. And then now, since we're treating this like it's its own number, you can times both sides by 6 over 25 to get rid of it from the right hand side. And then now you can see how all we get is this is equal to our n. So I'll write that here. And now we can simplify things. So this simplifies to 3 there. This 25 and this 2,500, this becomes 100. So we're left with n is equal to 3 times 100. So our answer is 300. This question is quite long and it has different parts to it. So you need to know how to combine and work through logs, and then you need to know how to solve a cubic as well. And that involves guessing one of the solutions, dividing through, and then using the quadratic formula at the end. I'll show you each part separately. So let's start with the logs first. Before you combine any log, it's important that there's no number in front of any of the logs. So we need to move this 2 up to the power using one of our log laws. So this becomes log base 3 x minus 4 squared, and then we have the rest of our equation here. Now what we can do is when you add logs, you multiply the insides and combine it into one log. So we get x minus 4 squared times the x from the other log equals 2. Now I hope you remember that you can rewrite logs as a power by writing 3 to the power of this equals this. Okay, so it's the base to the power of the answer equals whatever is inside the log. Now that we've done that, our logs are gone, and we have a different type of equation that we have to work through. So we have 9 is equal to x squared minus 8x plus 6. So I just expanded that square bracket. And then we get 9 is equal to what we have there. We can move everything to the right hand side. So minus the 9 across. And now we get a cubic. With cubics, we need to guess one of the solutions first. So the easiest is to guess x equals 1. When we sub that in, if it gives us 0, then x minus 1 is a factor. So when we sub in x equals 1, we get 1 cubed minus 8 times 1 plus 16 times 1 minus 9. 1 minus 8 is negative 7 plus 16 minus 9. And this all equals 0. Perfect. So x minus 1 is a factor. Now we can go on to the next part of our question. So now that we know that x minus 1 is a factor, we need to divide through by x minus 1 to get our quadratic factor. So we need to divide our cubic by the factor that we just got. So x cubed divided by x, that's going to give us x squared. Then you multiply this, so you get x squared times x gives us x cubed, and then x squared times negative 1 is negative x squared. Then you subtract. So x cubed minus x cubed is 0. Negative 8x squared minus negative x squared is plusing the x squared, so that gives us negative 7x squared. And then the rest just come down. Then we repeat. So negative 7x squared divided by this is going to be, divided by this, is going to be negative 7x. And then you multiply that through. So this times this, that gives us negative 7x squared. And then this times this, plus 7x, my bad. And now we minus. So this is going to be negative 7x squared, take away negative 7x squared is 0. And then 16x minus 7x is positive 9x, and then this comes down. Now that we've done that, we finally divide 9x by x, and that gives us plus 9. And then we multiply through. So 9 times x is 9x, and then 9 times negative 1 is negative 9. You minus these, 0 and 0, so we've found the quadratic factor. So our cubic can be written like this. So you can see that I put my factor from before, right here, and then our answer is the quadratic part. And remember that we were trying to solve this equaling 0 from the very beginning. So now we have our answer of x equals 1 for this bracket, or this part needs to equal 0. And it's not really easy to factorize that, so we need to use the quadratic formula. That's when the next part of our equation comes in. So I hope you remember the quadratic formula. You get x is equal to negative b, so negative of negative 7 is positive 7, plus or minus square root of b squared, so negative 7 squared is 49, minus 4 times a is 1, so we don't need to put anything, times c, which is 9, over, whoops, the whole thing over, 2a. And in this case, remember a is 1. So now we get 7 plus or minus, the inside here is 49 minus 36, which is root 13 over 2. Okay, so those would be my answers. But looking at our original equation, it's very important whenever you're dealing with logs to make sure that your answers fit the domain here. So remember that you can't have a negative inside of a log. So looking up here, I hope you can see that x minus 4 has to be positive. So x has to be bigger than 4. And then here, x has to be positive. So you can see how overall, as long as we make sure our answers are over 4, we are good. So looking at our answers, 1 is not over 4, so we don't include that one. And then we have 7 plus root 13 over 2. And then 7 minus root 13 over 2. Well, 7 over 2 is 3.5. And what is root 13 close to? Well, we know square root of 9 is 3. So this has to be a bit bigger than that. So what's 7 plus 3? 10. And you divide that by 2. So that would get you 5 if it was root 9 instead. So this means this is guaranteed bigger than 5. So this answer is good. What about this one? Well, considering that root 9 is 3, 7 take away 3 would be 4. And then divided by 2 would be 2. That is guaranteed less than 4. And root 13 is even bigger than root 9. So this number would be even less than 2. So this answer is not good. So our only answer should be this one right here. Here we need to approximate the area under this curve by using 3 different shapes, each with a step size of pi and 3. We know it's 3 shapes because you can see how the x-axis has been divided into pi and 3, then 2 pi and 3, then 3 pi and 3, which is the same as pi. And the way we form these shapes is we draw a line up from pi and 3 until it hits the graph, then connect it to 0, 0, then do the same thing at 2 pi and 3 and connect it to the previous point, and then finally connect our point on the graph at 2 pi and 3 onto pi, 0. And that forms our 3 shapes that we'll find the areas of individually and then add them up at the end to get our final approximation. So let's start with the area of our first shape, which is this triangle. We know the base length here is going to be pi and 3 because that's our step size. And then to find the height here, we just need to substitute in the x value at this point here when you look on the graph. And that's pi and 3. So we need to work out f of pi and 3. And that gives us this. And you need to know your exact values. So sine of pi and 3 is equal to root 3 over 2. And you can see how this simplifies to our answer over there. So now we know the height and the base. So to get the area of this triangle, we just do half base times our height. And that gives us pi squared root 3 over 36. Next, we need to find the area of our trapezium over here. So I hope you remember that the area of a trapezium is given by half a plus b times height, where this and this are your a and b. So it's whichever sides are parallel. We know our height is just the length between those 2 parallel sides, and we know that's pi on 3. So we know this is pi on 3. This lines up with the height of our triangle, so it's the same number that we found before, pi root 3 over 6. Now that we know that length, we can find the height here, and that's by subbing in the x value there, which is 2 pi on 3. So f of 2 pi on 3 is equal to 2 pi on 3 times sine of 2 pi on 3. Now again, you need to know your exact values, and knowing that this is the same answer as sine of pi and 3, so it's root 3 over 2. And then these 2's cancel, and you're left with pi root 3 over 3. So that's that height there. So now we can work out the area. So we get our area is equal to half A plus B times our height. So it's very important to be careful here as we add this up and simplify it. So inside the brackets, you can see how this is a 3. I want it to be a 6 so I can add these fractions together. So what I'll do is I will multiply it by 2 over 2. And you can see how that leaves us with 3 pi root 3 over 6. And then now this 3 and that 3 cancel. And then we're left with pi squared, because of these 2 pi's, root 3, and then 12. We're going to want to add these up eventually, so we'll probably want to make that the same denominator. So I can times this by 3 over 3, and that will get us our 36 at the bottom there. Now finally, we need to work out the area of this triangle. Now this height here lines up with the height of our trapezium there, and that was equal to pi root 3 over 3. So I can write that here. This base length is pi over 3, so this is nice and easy. The area here is just half base times our height. You can see how that gets us pi squared root 3, and then this times this is 9, and then this is 18. So we just need to add these up, and then we will eventually get our area. So now by adding these up, this is what we get. And then we plus the other area. And then finally we add our last area. So now looking at this, we can add the 2 on the left, and that's going to get us 4 pi squared root 3, 36, plus, and then leave the 1 on the right because the denominator is different. You can simplify 4 and 36 by making this 4 cancel, and then this becomes 9. And then what we can finally do is multiply this fraction on the left by 2 over 2 to get the same denominator as the one on the right. So we get 2 there, and then 18 on the bottom. And you can see how that leaves us with 3 pi squared root 3 over 18, and then this cancels with that, and our final answer is pi squared root 3 over 6. Following on to part B, we just need to find the derivative of the function that they gave us before, and we need to use the product rule, which I showed you how to use at the start of the exam. So you take the derivative of the first function, which is 1, times it by the second function unchanged, and then you add the derivative of the second function, which is cos of x, times the first function. So our final answer is sine x plus x times cos x, and that's it. This question is asking us to find the range of f dash of x over that interval. It's important to remember that f dash of x just refers to our gradient. So it's just asking us what's our lowest gradient and what's our highest gradient in this interval. So we need to use the derivative from the previous question that we found. So f dash of x, sine of x plus cos of x times x. So that was our derivative. And looking at our graph on the far right, you can see that our graph is the steepest at pi on 2. So what that means is that is going to be the upper limit of our range. Whatever the gradient there is, that's going to be on the right of our brackets for our range. So let's find out what the gradient there actually is. So you sub in pi on 2. And working this out gives us 1. So that means the steepest gradient in this interval is 1, and that will be the upper limit of our range. Then we need to find out what's the least steep that our graph is in this interval. Well, you can see that as we move along from pi on 2 to 2 pi on 3, it gets less and less steep. And then you can see how at 2 pi on 3, it's the least steep. So that's going to be the lower bound of our range. So let's find out what the gradient there actually is as well. And remembering your exact values, you get this. I hope you can see that these 2's cancel out, and we're left with root 3 over 2 minus pi over 3. So this is the least steep, this is the most steep. So our range is going to be this, 2, 1. But it's also important, remember the brackets. So you still include both ends. So it's very important that we write the correct brackets. So it should be a square bracket and the square bracket there as well. So remember that a curly bracket doesn't include either endpoint and the square bracket does. So for this question, we need to use the range that we found before, which was this. And what this is asking us is basically, is there a 0 in this range? Because remember that a stationary point happens when our gradient equals 0. And remember that this range gave us our lowest gradient and our biggest gradient in this interval. So if 0 is somewhere in between there, then we have a stationary point there. So what we need to do is just show that this number here is negative. And once we show that that's negative, well then 0 has to be between a negative number and 1 because our graph is continuous. If our graph wasn't continuous and it cut up somewhere, then it might not be in there, but it's continuous. So it has to go through 0 eventually. So if we just show that this left part is negative, we'll be good. So let's start with this number here. We know that this has to be less than root 4 over 2. So root 3 over 2 is less than 1. This simplifies down to 1. So we have a number less than 1 here. And then if we deal with the pi on 3, we know that this has to be less than, well, it has to be bigger than 3 over 3. Because if this is 3 point something, and then you're dividing it by 3, you're going to get a bigger number than if you did 3 divided by 3, because that would be 1. So we know that 3 over 3 simplifies down to 1. So now we have a number that's bigger than 1 and a number that's smaller than 1. So if we have a number that's smaller than 1 minus a number bigger than 1, overall that's negative. So that means this has to be negative. So therefore, our derivative is equal to 0 somewhere in this interval. And you say, since our gradient graph is continuous. Because remember, if it's not continuous, then it can cut off somewhere, or you might have a particular point that's not included, and you can't guarantee that 0 is going to come up in there. What we need to do is sketch the graph of our derivative. Let's write down what our derivative was from before. I hope you remember that our derivative graph, the y values of that graph, correspond to the gradients on our original graph. Let's first find the coordinates of our endpoints. So on our far left, we have x equals negative pi. Sine of negative pi is 0. Cos of negative pi is negative 1. And then times by pi. So that gets us pi. Our coordinate on the far left is negative pi, comma pi. And then on the far right, we need to sub in pi. Sine of pi is 0. Cos of pi is -1. So we times like that and we get negative pi. So on the far right, our coordinate will be this. What we need to do is look at the turning points on our graph. And it's important to understand that the gradient there is 0. It's a flat tangent. And those 0 values correspond to the y values on our derivative graph. So they become the x-intercepts. Then we can put our turning points because it tells us in the question that we have a local minimum and a local maximum and their respective coordinates. So we can plot that as well. And then we can put our endpoints. And now we can draw a nice smooth continuous graph that fits those points, and that's our derivative graph. So in this question it says let point P be the y-intercept of the graph. And then here it just says find the coordinates of P. So the y-intercept happens at x equals 0. All we need to do is just sub in 0. And that gets us the cube root of -k plus m. So our coordinate of P is going to be 0, comma, cube root of -k plus m. So you can see it says in terms of k and m, we have both of those in our answer, so that's good. Now it says find the gradient of g at P in terms of k. So we need to find the derivative first. And in order to find the derivative, it's easy if we rewrite our graph using a power. So we can write the cube root as power of a third. And then to find the derivative of this, you just use the chain rule. So it would be derivative of the outside, you bring the power down. And then minus 1 from the power, so minus 3 over 3 from 1/3 is -2/3. And then the m just disappears. And then you would times by the derivative of the inside, which is 1. So you don't do anything. Then it says find it at P. So that's when x equals 0. So sub in 0. And we get this. And remember that you can get rid of the negative power by bringing it to the bottom. And remember that this 2 at the top means that you're squaring whatever this is. And when you square a negative, it just becomes positive. So you can just write that as your answer. The next part says, given that the graph of y equals g of x passes through the origin, express k in terms of m. So if it passes through the origin, we know it goes through this. So you just set it equal to 0. And then put 0 into our graph as well. And it says express k in terms of m. So we need to find what k is. So move the m to the other side. And then now we can cube both sides to get the k by itself. And then we get k is equal to m cubed. When you times both sides by -1, that will get rid of the negative on both sides. Here, there are 2 things that are really important to do at the very beginning. It's important to know what this graph kind of looks like. So it's very important to know what does a cube root graph look like. It's the inverse of a cubic. You should know that it has an inflection point. And we can find what that inflection point by doing this. So we know that our graph goes through the origin, and it says that we need to write our answer in terms of m. So we don't want any k's in here. And the previous part of this question is really helpful because we found what k was in terms of m when the graph went through the origin to begin with. So that means that we can write our graph by getting rid of our k that we don't want anymore. So we can replace it with m cubed. And now, to read the inflection point of this, it's the exact same way that you read the turning point of a parabola, for example. It's just the opposite of that number, and then whatever number is there. So that's the midpoint. And to the left and to the right, that part of the graph is symmetrical. And I'll show you what I mean in a second. Let's first draw what our cube root graph looks like. As long as you make the graph go through 0, 0 and go towards the right hand side, then your drawing is good. Then we can label our inflection point as m cubed comma m. Then I'll just put a tangent line at point P so you can see the gradient there. So then what I would do is I would keep the tangent line in the exact same gradient. So your ruler, just imagine you move it up and see where it lines up with the graph. That'll be point Q. And you can see how as I change m, it doesn't really matter. The graph is going to always go through 0, 0, and those tangents are always going to be symmetrical about the inflection point. So to get our answer, it's very important that we understand the symmetry that goes this way. So no matter what our value of m is, those 2 points with the same gradient are always going to be symmetrical around this point. So if this length here is given by m cubed, well then by symmetry, this also has to be m cubed. So overall, that has to be 2m cubed. So that's the x-coordinate of this point here. And then let's think of the symmetry for the y value. Well, if this length here is m, well then by symmetry, this length here, this one here, has to also be m. So the y value there is 2m. So now we found the coordinate of q, and that's our answer here.